Okay, in this video, we're going to talk about surface area and then we're going to add a little bit of volume in at the very end. But talking about surface area, when we talk about surface area, we're actually talking about the amount of space that's taken up by a box if we were to cut it and then just lay it out. How much area, and this is two dimensions, it's length and width. Okay, so those are the things that we're talking about with surface area. It's how much area does the box itself take up when it's not a box, when it's just a sheet of cardboard or something. When we're talking about volume, we're talking about how much three-dimensional space a figure takes up, whether that's width, that's depth, that's height. Those are the things that we're going to talk about with that. So what we would do if we take this particular box is we would look at each of the different faces. Now, when we're looking at a rectangular cube, or square cube, whichever of those, we have to recognize the fact that there are 6 faces to it. There's a front, there's a back, there's a top, there's a bottom, there's a left, and a right. So when we get all of those, the dimensions of all of those, we can find the area of all of those rectangles. Then all we have to do is add them together, and that gives me my total surface area. So as we look at this, there's my cube. It's 5 wide, 6 high, and 7 deep. Okay, so the top, okay, which is this one right here, is 7 this way because it's the same as this one, by 5 this way, which is the 5 this way. So it's 7 times 5. Now the bottom is the exact same thing. So that one's 7 times 5. So that makes our life a little bit easier. The left-hand side, which is over here, is 6 high by 7 deep. 7 deep, 6 high. So it's 7 times 6. The right one is the same as the left, so that's 7 times 6 as well. The front is our 5 wide, 6 high, 5 times 6, and our back is also 5 times 6 because it's the opposite faces are equal to each other. Top and bottom, left and right, front and back, okay? So those faces are equal in size to each other in our examples that we've got up here. If they're not, then obviously you would have to make the adjustment for those individual measurements. So now we just do our arithmetic as we work our way down our list. So 7 times 5 is 35. 7 times 5 is 35. 7 times 6 is 42. 7 times 6 is 42. 5 times 6, which is 30. And 5 times 6, which is 30. So then all I have to do is add them up. So 35 and 35 gives me 70. 42 and 42 gives me 84, and 30 and 30 gives me 60. So then I have to add is those 3 numbers together, 0, 4, 0, which gives me 4, 6, and 8 is 14. 14 plus 7 is 200. So that's 214 units squared. Remember, this is a 2-dimensional figure. So, or it's 2 dimensions. It's only length and width when we're talking about each individual face. So we're units squared. So it's 214. So what would the volume be? How much 3-dimensional space would it take up? Well, that one we would just take the width times the height times the depth. So that becomes 5 times 6 times 7. So 5 times 6 gives me 30 times 7. 30 times 7 is going to give me 210 units cubed. All right. And let's look at our second example. Our second rectangular prism is a dimension of 3 wide, 4 deep, and 12 high. So as we look at our dimensions for our top and our bottom, okay, which are they going to be the same? So that would be 3 times 4. Okay. 3 times 4 for both of them. So the left and the right. So that's 4 by 12 on both. 4 times 12, 4 times 12, and then the front and the back, which would be 3 times 12, 3 times 12, 3 times 12. So then all we have to do is find our measurements, do our arithmetic here. We're going to add them all up. So this is 3 times 4 is 12, 3 times 4 is 12, 4 times 12 is 48, 4 times 12 is 48, 3 times 12 is 36, and 36. So 12 and 48 is 60. 12 and 48 is 60. And 60 and 60 is 120. So we've got 120 plus 36 and 36, which is 72, which gives me a total of 192 units squared. Okay, so for our volume, we would have 3 times 4 times 12. So it's 3 times 4 times 12, which gives me 12 times 12, which gives me 144 units cubed. So that gives me my surface area total and my volume total. Again, my surface area total and my volume total. All right. So remember, surface area is the two-dimensional space taken up if we were to lay the box out. And volume is the three-dimensional space that is taken up when the box is actually a box. Thank you.